Thanks for tuning in. We're just going to go over some problems on IXL, and this has to do with substitution that we talked about in class. So substitution is when you replace one variable, in this case x, and every time we see the x is now 3. So we're going to substitute x for 3. So in this problem, -5, x has now become 3, plus y is equal to -12. So that we solve for x already, we still need to find the variable y. We're solving for this system of equations where we have an x and a y. We're going to go ahead and simplify. Let's distribute the 5 and the 3. So -15 plus y is equal to -12. Solving for y. Right, we're solving for y. We have to get rid of the 15. We add 15 to both sides. Opposite operation of -15 is +15. Y is equal to 3. So what you have to do when you're solving a system, you have to say, okay, x is, we said, was 3, and y is going to be also 3. Okay, that is our solution. That's our x and our y. And just to double check that, in our first problem, well, x is 3. That works. We had x is 3. The second one, just to verify it, double check. -5 times 3 plus 3. Does that give us our -12 that we were hoping for? -15 plus 3 is -12. Okay, for our next problem, they told us x is 3, so we just go ahead and use substitution. Substitution is really nice because when they do give you what x or y is equal to, we can just plug it in to solve for the other variable, in this case, y. Okay, we can distribute the 2, that's -6 plus 2y is equal to -8. Opposite operations, we're going to add 6 to both sides. And we're left with 2y is equal to -2. So remember, a positive 6 and -8. -8, we have more negatives, so we're going to be left with -2. Then we can divide both sides by 2. Y is equal to -1. So to state this in the correct way, the solution for the system is when x is 3 over here, y is going to be -1. So in this version, x is -2. So take a look, x is -2. So we still have to solve for y. So we just substitute -2 as our variable x. And we're going to copy everything else out. We'll distribute that 7 by -2 is -14. Minus y is equal to -16. Now, we want to be careful here because we see a -14, so the opposite of -14 is +14. We're going to add 14 to both sides. To the other side, remember we're trying to solve for y, so we need to move all the values over. It's 14. We're left with y is equal to -2. Now, this is a preference depending how you want to do it. You can divide both sides by -1, or you can multiply both sides by a negative. I'm just going to write divide by -1 to both sides. That is okay. Y is equal to +2. So our solution is, the claim is, x is -2 and y is +2. Let's just double check it so we can practice. 7 times x, substitute -2 in there, minus y is +2, substitute y in there, and -16. Let's see if this is a true statement. -14 minus 2, that does become -16. So we found a solution for the system. Here's the last type of substitution question we're going to see for today. We have two equations solving for two variables. Now, instead of giving you a number, we are given that y is equal to and y is equal to. I want you guys to notice that y is equal to, y is equal to. Well, if we want these to be the same y, that means the y's have to be equal to each other. Okay? And I'm going to show you guys a little differently. I'm going to use little colors here so you guys can see that a little bit better. So we have yellow y is equal to the red y. They should be equal to each other. If this was a solution for the system, the y's would have to be the same. If one was 3, the other one would be 3. If one was 5, the other one would be 5. In this case, y the yellow y is 5x minus 10. The red y is x plus 6. And what we did was we substituted our variable of y and y. So now we can solve this equation. We went from two variables in a system of two equations to actually only one variable. And that's our main goal. We write, instead of having two unknowns, we substitute and we only end up with one unknown. And that is the goal. Let's go ahead and see that this is now an equation with variables on both sides. So we're going to combine the variables first. I have more x's on my left, so I'm going to move the x on my right over. Opposite of plus x is subtract x to both sides. We have 5 minus 1 is 4. X minus 10 equals to 6. Now this is a two-step equation. We're going to get rid of the 10 first. Opposite operation minus 10 is add 10 to both sides. 4x is equal to 16. And then we can now, a one-step equation, opposite of multiply is divide by 4. X is 4. Now, the problem here is I know what x is, but I don't know what y is. So we're going to substitute again, knowing that for the system, x has to be 4. You can pick any of the equations. I'm going to actually do them both here. Let's use the yellow equation. Y is equal to 5x minus 10. And we know what x is. We said x is going to be 4. So y is equal to 20 minus 10. 20 minus 10 is just 10. So we're claiming that if x was 4, y has to be 10. Well, let's see if that worked for my second equation. If that was true also. So which equation do you choose? You get to choose whichever one you think is going to be easier. And that's really the judgment call for you. Equals to x plus 6. We said x for sure was 4. And y is equal to 4 plus 6 is 10. Hey, they're the same answer. They're the same answer. And they should be. Our goal is to find the same y, same x and y for both equations. And if I want to double check, if I say, is 10 equal to 5 times 4 minus 10? That's 10 is equal to 20 minus 10. Yes, that is a true statement for the first equation. And the second equation, y is equal to 10 and x is equal to 4 plus 6. 4 plus 6 is 10, so 10 is equal to 10. So this answer of 4 and 10, x and y, is true for both equations.